So we're going to finish section 2.3 by picking up where we left off last time with shading in Venn diagrams. And so let me just remind you of the couple that we had done. We had done this first one, and it just had two circles because it only had two sets listed. So we drew two overlapping circles. We numbered all the circles, and then we looked at each of the individual components, combined them with unions or intersections. And once we got to the very end, we went back and we shaded the picture to represent the numbers that we had gotten. It got a little bit more complicated over here because we had three sets. So we had the three overlapping circles. We still numbered all of our regions. We still identified all of the little individual numbers within those regions, looked at unions and intersections, and then shaded when we were done. And this one combines both of those features. So this one also uses some complements. So we did question A here, which had complements in it. We did question B, which had the three sets. And now I'm going to kind of combine both of those together in a single problem. All right, so for starters, you're going to draw your Venn diagram. So you're going to draw your rectangle, and I have three overlapping circles. And you're going to label them A, B, C, and the universal set on the outside. Okay? And you're going to, oops, let me move that C down a little bit. It sort of feels like it's in the way. Oh, good grief. Keep hitting cancel. Done. Okay. We're going to number our regions the same way we did last time. So across the top, we're going to do 1, 2, 3. Through the middle is 4, 5, 6. At the bottom is 7. On the outside is 8. And again, there's nothing special about my numbers. I think there might be even some examples that might use letters in your book for some specific problems where you're doing the same sort of thing, but this is one option. Okay, so we start inside the parentheses. And inside the parentheses, there are two individual components. There's an A and a B complement. So we're going to find each of these lists of numbers. So what numbers are inside of circle A? Right, 1, 2, 4, and 5. And what numbers are in B complement, which means outside of B? 1, 4, 7, and 8. Okay, does that make sense to everyone? Okay. What's the symbol that they're using to join these? Intersection, and what does intersection mean? Both. It means that what they have in common. Okay, so the pieces they have in common. So again, remember, intersection of streets, right, where the streets cross. So they have a 1 and they have a 4. All right, so now we've done everything inside the parentheses. We're going to move outside the parentheses, and we need to put C complement down next. C complement, everything outside of C. So what numbers are outside of C? 1, 2, 3, and 8. And what operation are we using to join these together? X intersection again. So again, on this one, it's what they have in common. Okay, so sometimes we use two intersections here. This one over here had a union and an intersection, so pay attention. They don't always follow anything. They could be either. So what numbers do these have in common? Yep, just the number 1. So going back and shading, I will shade only region 1 for my answer. Does that make sense? Okay. I would have liked to have gotten through the end of that one last time because it's a more natural breaking spot, but that's okay. So shading is one of the things, sort of identifying the location in the diagram or locations that a set operation is actually identifying for us in its form. The other thing that we're going to be doing is we're going to be actually putting numerical values in these that are not just placeholders, right? These are placeholders. The value 1 here doesn't mean one item, right? But as we move into the next piece, it's going to. So we're going to take a look at these in terms of cardinalities. So what these are actually telling you now, notice, is that they have that little N in front of them. Do you see each one that's listed here? The N in front? It means the number of objects, elements, whatever, that are inside of the region it's describing. So this one does describe 3 circles because I have circle A, I've got set A, set B, and set C all described in the notations here. So I am going to draw my Venn diagram with 3 circles. and label them with whatever labels they're given in the particular problem. This one is A, B, and C, and the universal set on the outside. Now, here's the thing. The first one at the top where it says n of A is 24. That means the entire circle A, all of the pieces, and there's 4 different pieces there, right? Combined have to be 24. There's a lot of ways that I could break apart the number 24 and put them in those 4 different areas, right? What that tells you is that that's not where we're going to start the problem. The goal is not trial and error here. There will be no trial and error needed. If you start in the right location or locations, sometimes you can start in a couple different places, you'll know for sure a number that goes somewhere. There's no need for guess and check here, okay? So this is not the place I want to start. So that's also true for n of B and n of C, right? I don't want to start there. There are going to be these 4 different places I could put numbers that have to add up to the 24, 24, 26. That's not a good place to start. So let's take a look at the next one. It says A intersection of B. Well, that's this region. And while there aren't 4 different spots, there are 2. So if I start here, again, I have to use some trial and error or guess and check because I need numbers that add up to 10. Well, maybe it's 10 and 0 or 9 and 1 or 1 and 9, right? I mean, all those options are trial and error. That's not where I want to start either. Okay, so that's that line through the middle on my screen, intersection of A, the intersection B and C, the intersection of A and C, all of those give me 2 different regions. So let's go to the bottom line. This one right here says A intersect B intersect C. Where is that? It's the very middle, right? It is this piece here. There's only one place where it identifies it, correct? Now, it doesn't always start with the intersection there in the middle. That doesn't always happen. This one did. So this piece here in the dead center is one location, and it's the location then that we have information about where we don't have to guess and check. So we're going to do, actually I'm going to leave that hiding there, a 6 there in the middle. Okay, is that good? Okay, let me mention the last one, the one that's listed after that over here. This piece over here is not the outside box. It means the entire box with the outside piece and all 7 of the regions inside. So it's all 8 of them added together. So that's definitely not where we're going to start. It is where we're going to end on this one though, okay? So that's going to be our last one that we're going to do. All right, so we're going to actually work our way sort of back up the descriptions that we have here. So if I go back up a line, and now I'm looking at A intersect B, it's still the same region, but I know one of the 2 numbers. So again, there's no guessing and checking, there's just subtraction, right? What number has to go in the missing piece? It'd have to be a 4 right here, because these 2 numbers have to add up to 10. So I have a 4 right here. How about B intersect C? So that's this piece. Those have to be an 8, so I need 2 in it. And A intersect C over here, have to add to 15, which means I need a 9. And everything through the middle has been done now. And I do think it's a good idea to somehow keep track of the pieces that you've used so that you're not trying to figure out, did I use it or not later? Just keep track, mark them off as you do it in some way. All right. Again, moving back up the line. Let's go to the top. While this is still representing 4 pieces, 3 of them are already filled in. I have a 4, 6, and a 9, and the only piece that I don't have is the outside piece of A, okay? And all 4 of these have to add up to what? 24. So how much do they add up to right now? 19. Okay, so I've already got them adding up to 19. So how many more do I need? 5. So now there's a 5 in the region on the outside. Circle B. All of this has to add up to 24. 3 of the 4 pieces are filled in. How many do they add up to right now? 12. So how many are remaining? 12. And this one's taken care of. And then the last one, 26 for C, not the last one, but the last one on this line, is this circle, has to add up to 26. How many does it add up to right now? Okay, so how many will remain? How many? Is it 9? I have something written down wrong. Oh, no, I was looking at the wrong problem on my paper. Thank you. It's 9 on there, too. Good. So we have 9 out here. And we've taken care of the last one on the top line anyway. And the last thing that we have then is to take care of this piece so that all of them add up to 50. Okay, so take a minute. There's 7 numbers in there. Add the 7 numbers up that you have. What do you have? 47. So how many are left over? 3. I need 3 more on the outside. Okay, so I feel like this is just like a Sudoku thing. This feels like that kind of a puzzle. And, you know, I kind of like puzzles for their own sake. They're kind of fun. I like Sudoku. I like stuff like that. So that's great. But there's really actually like purpose behind it too. It's not just for the fun of filling in numbers into a diagram, okay? So the last 2 examples that we have show what we've actually been building up to through this entire chapter, really, okay? Which is taking a look at some context questions that we can use Venn diagrams to help us solve. So here's our first one. Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2. He wrote a total of 5, and he produced a total of 7. Okay? We're going to draw a Venn diagram representing this. The first question I have for you, I have space over here, and you have your paper you're going to look at, is how many circles do I need according to this description? 2. I'm not going to label them with letters. I'm going to label them with descriptions. What are these circles representing in our context? Yep. Wrote, right? Projects he wrote. And projects he produced. We'll abbreviate that. And I'll still call this the universal set out here. Okay, everybody good with the basic setup first? Okay, good. So there's 4 pieces of information here. Let me underline them. It says he worked on 12. It says he wrote and produced 2. It says he wrote 5 and he produced 7. There's 4 pieces of information that we have to somehow place in this diagram. Which one is the one we should start with? Wrote and produced. Yeah. That word and is intersection, right? It means both. So this piece right here, wrote and produced 2, tells me where does that 2 go? In the middle. Okay, is everybody good with that? So while many times in problem solving and in mathematics, you can go about things in lots of ways, there really is a very natural place here to start, and we need to look for it. Don't go making things harder than they have to be. There will be a natural place to start, okay? And it's not always in the middle. This one is, but it's not always in the middle. All right, so we took care of one of them. What would you like to look at next? Now we have a little bit of flexibility. Wrote 5. Okay, so we'll go with wrote 5 next. He wrote 5. So what does that mean? Good. So this whole circle is 5, which means the outside part is 5 minus 2. Don't get carried away and just put a 5 out there and think you finished it. Okay, be careful. The whole circle has to be 5. So there's a 3 on the outside here right now. All right, the next one is produced 7. It's a good place to go next. He produced 7. So what does that tell you in the diagram? Yeah, 7 minus the 2 in the middle gives me 5 on the outside. So these 2, the 5 and the 2, are going to add up to the 7 that he produced. Okay? There are some questions that will say something like, in context of this one, it might say one of the projects he only wrote. If you use that word only, that would tell you the outside region, right? It would tell you he didn't produce it as well. So he only wrote 2 or only wrote 7 or whatever. Then you would put it in the outside part by itself. But they use the word only when they're describing it that way. All right, our last one says that he worked on 12. What is that telling you? Yeah, it's telling you that there should be 12 total in the diagram, and right now there's only 10 out there, which means there's a 2 missing on the outside. Okay, so there's my mini version of this so we can look at it for answering our questions. All right, so we have 3 questions we're going to answer. The questions to answer are usually very straightforward after we do the work of the diagram. Okay? So within this diagram, how many projects did he write but not produce? That would be the 3 on the outside, right? This is the writing only part I was just describing. How many did he produce and not write? 5. And how many did he neither write nor produce? 2. Okay. We'll see some variations of questionings in the next one. Is this okay for this one? All right. A youth group was asked questions regarding songs they'd learned as children. Upon surveying the 34 youth, the following were obtained. 15 had learned Jesus Loves Me. 19 had learned the B-I-B-L-E. 28 had learned This Little Light of Mine. 13 had learned Jesus Loves Me and This Little Light of Mine. 15 had learned Jesus Loves Me and the B-I-B-L-E. 14 had learned the B-I-B-L-E and This Little Light of Mine. And 13 had learned all 3. Okay. First question, how many circles are in my diagram? 3. Okay. So we're going to go over here. We're going to draw ourselves a circle. Put it over here 2 slides over. And I need 3 circles. What are these 3 circles going to be labeled? Okay, I'll write it as Jesus. How about? B-I-B-L-E. And This Little Light of Mine, so I'll abbreviate it as light. And I'll still label this as U on the outside. Okay, does that make sense? Okay. Oops. All right, lots of pieces of information. Where shall we begin? The 13 on the bottom. 13 had learned all 3. Okay, I keep telling you they're not all going to start in the middle, but all of my examples do. So I should probably do something about that next time I teach the class. But anyway, they do have 13 in the middle. Okay, is that right? All right, what would you like to look at next? The one right above it. We can go up the line. All right, so we have 14 are the B-I-B-L-E and This Little Light of Mine. So the B-I-B-L-E and This Little Light of Mine is this piece right here. It's got to be a total of 14. So how many are missing in the outside section? 1. So I'm going to put a number 1 right there. Okay, is it good? Next one you want to do? Next one up. All right, 15 had learned Jesus Loves Me in the B-I-B-L-E. That's this piece. Total of 15 means I'm missing 2 to put right there. Next one up. 13, Jesus Loves Me in This Little Light of Mine. So that's this piece over here. So what? There'll be a 0. Okay, zeros are perfectly fine. Negatives are not. These numbers are representing people. I mean, in this case, right? The last one was representing types of projects, but they're representing objects. They have to be whole numbers, which means 0 is okay, negatives are not. Fractions and decimals not okay either, okay? But 0 is okay. All right, cool. Now what? Sure. You can't always just go up the line, but this one works really nicely to do so. 28 had learned This Little Light of Mine. So This Little Light of Mine is this entire circle. It's supposed to be 28. So I need 14 more out here. Very good. Then what? 19 for the B-I-B-L-E. Okay, so that's 19 right here. How many are already there? 16. So how many am I missing? 3. Good deal. The next one, sorry, I keep flipping screens. There's just no way to fit it all on there and be big enough for y'all to see too. So that's the way it is. Let's see. I'm running out of colors. 15 had learned Jesus Loves Me. So this one is supposed to be 15. Was it 15? Okay. How many are in there already? 15. So what does that tell you? There's a 0 out here. Okay, good deal. And then there's one more piece of information that I haven't dealt with. Do you find it? Yeah, the 34 youth at the beginning, right? That's how many people were surveyed. What does that tell us about this diagram? Tells us how many total it all has to add up to, right? Everybody that's present, all these numbers have to be a total of 34 individual people that they have interviewed or whatever, surveyed. How many are already there? 33. So how many are missing? 1. Yeah. So I've got a 1 on the outside. Okay, so here's my mini version over here. We'll answer our questions. Oh. There we go. All right, the question first one says, how many had learned exactly one of these songs? So what portion of the picture would that be describing? Okay, it's the outside circles, right? So the one that's got 0 out here with Jesus, the 3 out here with the BIBLE, and the 14 out here with light. Right? Those are the exactly 1 regions. And I'm going to write them down. So this is 0. What did I say it was? 3 and 14. So that total would then be 17. So 17 had learned exactly one of these songs. What about the phrase at least 2? What does that mean? 2 or more. And here we're doing 2 or 3. So it's going to be all of the pieces that we have overlapping here in the middle, like this, right? Is this kind of, I don't know, I want to say boomerang, but that doesn't quite look like a boomerang either. So whatever this shape is, this whirly bird thing in the middle here, right? Okay. So I need those numbers added up. So I have 2, 0, 1, and 13. For a total of what? 16. How many had learned none of these songs? 1. That's the ones on the outside region. And how many had learned this little light of mine only? 14. So there's that phrase only I mentioned before too. Okay. All good? Okay, we're going to finish with something that shows up like in a section C kind of a problem. And we alluded to this a little bit last time. We talked about the commutativity of intersections and unions is the one we did. So commutativity with intersections and unions we had. In fact, let me just flip back to it so you can remember what I'm referring to. This one. We talked about the sets A intersect B can go that direction or B intersect A, and we did it also with A union B and B union A, right? That's commutativity. The order doesn't flip and hurt anything, right? And we talked about the fact that if we did relative difference, it would. The relative difference is this outside shading of one region compared to the outside shading of the other one, so it wasn't commutative. This question is asking us about the Cartesian product. So the Cartesian product is the one where we do the ordered pairs. So is the Cartesian product commutative? Why or why not? So I'd like for us to take a look back at the Cartesian product we did last time to examine whether or not this should or should not be commutative. Okay, so this was our definition of A cross B, right? I'm going to create ordered pairs where the first ordered pair A comes from the first set, A, and the second letter in the ordered pair B comes from the second set, B. And I did an example down here where A was the numbers 1, 2, 3, and B was the letters A and B. And we found these specific ordered pairs. If I had done this reversed, would I end up with the same ordered pairs? Let's try it. Let's try it. If we don't see if it works or not right away, let's just try it. So let's find B cross A. So B cross A means taking an element from B, which that's the letters. So I've got like the letter A, right? And I take an element from A in this order, and I have a number 1. Or I can have an element from B that's, let's continue with A. With the A that's the number 2. Or I can have the element A from B, which is paired with the number 3.
And you're just stacking it for space?
Yes.
Okay.
I'm running out of space on the side. You could write all 3 of them beside each other lengthwise too, if that makes it more sense. I would like to write it that way myself if I did it. Yeah. You could also just write them all in one long line. There's no reason to stack them at all. I just need space issues here. And then I could do the same thing with the second element in set B, which is the letter B. So I could group the letter B with the number 1 in set A, the letter B with the number 2 in set A, and the letter B with the number 3 in set A. So this one is A cross B, and this one is B cross A. Are they the same? No, they're not the same, right? They have all of the ordered pair pieces are reversed. Every single one of them is flipped. Okay, so over here, the question is it commutative? And the answer is no. And specifically, or for an example of why not, you're going to have an ordered pair. We'll just use one of the ones we did, A1. And it's not the same as the ordered pair 1A. It groups the same elements together, right? The grouping is the same, but the ordered pair is not the same. And if you think about it from like an XY ordered plane, right? Just our regular XY ordered graph, you know this, right? The ordered pair, say 2, 1, is not the same as the same location as the ordered pair 1, 2, right? They're different places. So if it helps to think about it from the perspective of a graph, you can do that too. Okay, does that make sense? So this is why it's not listed in the list of different properties that we had earlier, is because it isn't a property.